All righty. So good morning, everyone. For those that are rolling in still, you've come to the right place if you're here for the Eastern Region Science Sharing webinar on applying prob severe LightningCast. Again, welcome everyone virtually to the next Eastern Region Science Sharing webinar this morning. A couple of notes before we get started. So first off, this webinar is being recorded via Google Meet. So per Google recording policy, we kindly ask that you keep your cameras and mics both off and muted during the duration of the presentation. And then at the conclusion of the presentation, we'll have time for a Q&A and field any questions, comments, or concerns, ideas you have about LightningCast, and we'll take it from there. So this morning, pleased to introduce Mr. John Cintineo. John, thank you so much for being with us this morning for our next webinar. This morning, talking about applying prob severe LightningCast for NWS operations. So before we get started, a background on John, first and foremost. John received his bachelor's degree in atmospheric science from Cornell University and his master's degree in meteorology from the University of Oklahoma. Since graduating from OU in 2011, he's been with the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison, and he's been the primary developer of the prob severe portfolio of models, some of which are in widespread use across NOAA's National Weather Service, of course, as many of us are aware of this product, but some of us may not be, and we're here to learn more this morning. He's also been involved in research regarding volcanic ash cloud detection and diagnostics therein, and with NOAA's next-gen fire system. So with that said, John, thank you so much for being with us this morning in the Eastern Region and beyond Eastern Region, across the agency this morning. Welcome to the Eastern Region Science Sharing webinar series, and the floor is yours.
Yeah, thank you, Jordan. Thanks for the introduction. Thanks for the invitation. Enjoyed talking about prob severe, and want to thank my colleagues, Mike Pavlonis, Justin Siegliff, and Lee Krantz on all their work in the prob severe team. So I'll go ahead and get started. Really brief outline here. I'm just going to give a quick overview, some things that I've learned from forecasters and working in the HWT and elsewhere. Some things I think the forecaster should keep in mind when applying LightningCast to operations, and then kind of where we go from here, next steps. So let's go ahead and get right into it. So LightningCast is what's called a deep learning model. It uses images of ABI data to predict next hour lightning occurrence. And it's really this spatial and multispectral coherence and coincidence of the data that gives these image-based deep learning models their predictive power. Now it's next hour lightning occurrence as observed by GLM. So that means the target or truth data are the basically 60-hour accumulations of GLM flash extent density. Most of you are probably aware of flash extent density. It's basically just the number of flashes that traverse a given location in a given period of time. So that's all it is. And the inputs in LightningCast, just 4 ABI channels: the red band, 0.64 micron reflectance, the snow and ice band in the near infrared, 1.6 micron reflectance, and 2 long wave IR bands, 10.3 micron brightness temperature, 12.3 micron brightness temperature. One important aspect that LightningCast seeks to exploit is this day cloud phase distinction RGB, which a lot of you, I'm sure, use routinely. It's very good at helping depict glaciation and convective initiation. The pair of the 10.3 micron brightness temperature to 12.3 micron brightness temperature are what's called split window difference, useful for a number of things, but under certain conditions, you can see pooling low-level moisture. And also both are important for cloud top height determination. So you can see on the right here, the output of LightningCast is basically just a pixel map of the probabilities of 1 or more flashes as observed by GLM in the next 60 minutes. So of course you can contour these contours, and I'll be showing a number of animations, but basically this color map of the probability contours. LightningCast was trained on data from 2019 from each month, but heavily weighted towards the warm season where we have more lightning. Okay, so a primary goal of LightningCast was to predict lightning initiation. So why are we doing that, right? NWS doesn't have a lightning warning product or anything like that, but initiation is really important to decision support services and venues with high vulnerability. And it does seem like in the last decade or so, maybe more, the Weather Service is having an increased focus on providing those services to the public, especially for really large venue, high vulnerability type situations. So that's kind of the motivation. So while LightningCast, I think, predicts lightning initiation well during day and night, it does perform a little better during the day. That said, under certain conditions, it can still predict initiation well at night. From these two figures, you can it measures critical success index on the y-axis, month on the x-axis. But you can see that we have better performance, higher CSI, kind of in the April to October timeframe. November, December, and maybe a little bit in February and March, it's a little bit worse. And your most skillful probability threshold is higher, whereas in the April to October timeframe, it's pretty consistent, and kind of this 35 to 40%. That is the threshold overall, when aggregated together, that maximizes your CSI. So it's what we call, I guess, the most skillful threshold. We do see some over forecasting bias overall, more so in the winter months, where basically we're forecasting too hot. The probabilities are too hot. You want this line to be on the one-to-one, the red line to be on the one-to-one line. That would imply perfect reliability or calibration of the probabilities, which means the probabilities mean what they say. So when LightningCast forecasts a 40% probability, 40% of the time, it validates with lightning in the next hour. Okay, so like I said, predicting lightning initiation was a primary goal, and what we've seen when we measure lead time to the first GLM flash, we're getting a median lead time of about 15 to 20 minutes in kind of the middle probability, measured from the middle probability threshold. So we think for a number of situations, this is really good gainful lead time. A lot of times this is before you get anything really substantial on radar, and 15 to 20 minutes, I think a lot of users can take some action in that time. So that's the median, but also there's a pretty strong tail where you have 25% of the time, users, LightningCast can provide users 30 minutes or more of gainful lead time to take action. So we're pretty happy with this, and we think there's still room for improvement. And of course, we want to keep pushing the envelope and see how far we can skillfully extend that lead time. So LightningCast is available in AWIPS and GR level software, which probably you all use. That'd be the way you guys would probably obtain the data the most. It's also available on the web, and we have a combination of parallax corrected data and uncorrected. We try to parallax correct data whenever possible, just to make it more in line with radar data, basically. And so we run LightningCast over several sectors, including GOES East CONUS, GOES West PACUS sectors, the 1 minute mesos sectors, and a few other sectors as well. One thing that some of you may be aware of, maybe some of you aren't, and this would be via the internet only, are these lightning dashboards. So basically what that is for a number of static and dynamic locations, we provide time series of how LightningCast probabilities change, and how the GLM observations have changed over the last whatever amount of time you want. So this is for a specific location. So we have, I think, all TAF airports and Division I college football stadiums. So those are the static locations. We also provide this for wildfire incidents. And these are dynamically changing, right? These get updated all the time. And one thing I'm going to touch on the end is this automated on-demand system of dashboards where basically you can submit a time and a location, and then you'll be able to have this dashboard valid at that time. So I can talk about that at the end. So I do want to kind of show how to interact with this a little bit if you're not familiar with it. So basically, you go to our webpage. You can probably just Google search LightningCast. Let's see, and you can click on these dashboard links. It'll bring you to the page. Or what might be more useful is clicking on the layers here. Oops, let me pause this real quick. Yeah, click on the layers for the airports, for stadiums, for the wildfire incidents, and then you can go ahead and click on one of these dots and click the link in there, and it brings up the videograms. Now it defaults to the last 60 minutes of data, LightningCast probabilities and GLM observations, but you can change your time. You can change your time zone. I think we default to browser time, but you can easily switch it to UTC. So you can go back in time. So it looks like here I'm changing it to the last 3 hours, so you can see where LightningCast really began to increase here. So in the yellow is the 1 minute time series. So that's basically valid for the mesoscale sectors. The red is the 5 minute time series of LightningCast. So that's of course valid for the CONUS sector. And the blue dots, the little blue dots, are for GLM flash centroids within 10 miles of this given location. And the bigger blue dots are within GLM flashes within 5 miles of a given location. So you can highlight and zoom in, be as specific as you want. You can view this in a full panel to make it a little easier to see things, perhaps. You can toggle on and off different time series. You can do just 2 or 3. If you do I think it's like a command or control click. You can just do 1 at a time if you want. And you can go back in time quite a bit. I think we have an archive of about 6 months or so. So here I went back to 7 days, changing the airport to Atlanta International. I'm going to look at just another event, and again, highlight, zoom in what you want to look at, and you can clearly see how lightning potential has how it changed during this historical event as well. So hopefully this gives you a little idea how to play around, how to interact with this data. Hopefully this will be easy to share with users if that opportunity arises. And right now this is available just through the web. Okay, so I want to share just a few things of what I learned from forecasters. And one thing is that forecasters really only care about parallax corrected LightningCast data. In the hazardous weather testbed, we provide corrected and uncorrected data, but 99% of the time, forecasters are really just looking at the corrected data. And we use a constant cloud height assumption of, I think it's 9 kilometers or about 29,000 feet. But it's not perfect all the time, but in general, that seems to work pretty well. You'd want to use the uncorrected data when you're looking at I think satellite imagery, because it lines up more one-to-one then. So I think we're going to keep providing both in AWIPS, but it seems like forecasters really want everything in the radar centric reference frame, and that's fine. Another thing I learned is that understanding how or why the model makes the predictions it does really isn't a priority, especially when during warning operation or whatever operations, and you just have a lot going on, a lot to look at. It can't really spend too much time diving into the nuts and bolts of the models. It seems like building up experience and trust with the output is the way to go. And once folks have seen it enough and they trust it, they'll just use it. And something like understanding and unpacking the black box of the model is better relegated towards a training exercise or something like that. I'm going to share a couple of unexpected uses of LightningCast at this year's hazardous weather test bed. So in this case, forecaster was monitoring and warning convection that evolved into linear wind-producing storms, and he used it, basically the 75% contour, to know how far east to extend the warning polygon. I thought this was really, really interesting. I think it makes some sense, right? If you have a really high confidence, which 75% would indicate of where the storm is going to be potentially in an hour, and that's likely where the cores of your storms are going to be, likely where most of the severe weather is going to be. Now, obviously, you don't want to use this blindly, right? You wouldn't want to put your warning box way back here where, you know, there's some chance of stratiform lightning, but obviously that's not where the storm is heading. So this was probably a very unique way of using the data, probably very infrequently used this way, but it was kind of interesting. Another forecaster saw LightningCast give some advanced notice of a splitting storm or diverging storms in North Texas here. And you can see this in this image here, where you have this really big bulge of a very high probability contour, 75%, well north of the convection. So we want to look at this a little more closely. And here I just have the viz. I thought maybe we can see it a little bit easier in here. Here you have the splitting storm, and that's tracking northeast, where you have that bulge of probabilities, and that actually follows that that bulge pretty well. So what we did, what we did was ask the question at this time, 1931Z, and at this location, why is the model predicting a probability of 75%? So there are tools to unpack this black box. Explainable AI is kind of the phrase, and that's a really burgeoning field of science. So one tool we use is called layer-wise relevance propagation, and all it means is basically it can help determine how relevant or important is each pixel in each predictor of your model, to how much is it contributing to that prediction. So let me explain this a little bit. The black X's here correspond to the red X in this image. The probability of lightning predicted was 74% at that time. So at the bottom row shows this relevance or importance metric for each channel, and each channel is represented by a different column. And of course, the top row has the reflectance and the brightness temperatures for each predictor channel. So there are a few interesting things to point out here. Okay, clearly your location's proximity to cold, high textured cloud tops is important. That's not surprising. But something else that maybe I didn't quite expect was that you have some really strong gradients in the near IR and channel 15 here. These are strong cloud edge gradients. So I don't think the model has learned that there's a splitting storm per se, but it's basically, I think, learned that the strong gradient is indicative of a rapidly expanding anvil, and thus a thick anvil, thick ice, and thus there's higher chances of lightning in your location here. So this was kind of interesting to see, and really neat tool to help unpack what's going on in the model and provide some, not only a sanity check for, you know, is it learning what we know was true about storms and convection, but also perhaps some new insight. Okay, a few things to remember when applying LightningCast, and I've come up with 4 here. And the first is that the model LightningCast has learned patterns holistically. It's not just one thing or the other, but it's everything combined. I'm going to try to demonstrate that with this example from North Texas. So you have strong convection moving in from the northwest into Denton and Dallas counties. Then you have this tongue of higher probabilities of lightning extending into Dallas County. You get lightning initiation, and pretty soon you kind of get lightning pretty much everywhere. So I'm going to go ahead and break this down a little bit at a couple specific times. So here, the strong convection is still well to the northwest, but you start to see this tongue of elevated probabilities, especially in Denton County. Using the same technique as before, we asked, so why do we have this higher tongue of probabilities here? And there are a few things that stood out. Firstly, there's plenty of low-level moisture, right? Denton County is socked in and with low-level clouds. Secondly, you have some pretty close proximity to the deep convection. You know, it's about a county and a half away. Thirdly, it does seem, it's hard to know this exactly for sure, but it does seem like the LightningCast has anticipated some motion from not only the deep convection back here, but this more agitated convection in Parker, Tarrant counties. And right, Denton County kind of looks like, you know, Hood and Johnson County down here, where there's lots of low-level clouds, but probability is less than 10%. But Denton, right, you have over 50% in the kind of the northwest part of the county there. And then you move ahead 9 minutes later, the probabilities extend higher further south into Tarrant and Dallas County. You have a 75% contour here. And clearly at this point, there's another very important factor. You have clear glaciation in some of these cloud tops here. So I think all of these are contributing to the higher probabilities of lightning. Now jump ahead another 9 minutes and you get your first GLM flash. I think this is basically right over DFW airport. So I want to jump ahead here. This is 1534Z. Lots of lightning occurring in Denton and Dallas counties. I want to highlight this region and transport it back 41 minutes where we had kind of the start of, I think, of the 75% contour. So obviously, so these LightningCast probabilities are from 41 minutes prior, and obviously it's not perfect, but it seems like this tongue was definitely onto something, having this protrudence of higher probabilities well ahead of when you got a lot of lightning in those counties. Okay, second point, LightningCast isn't magic. It's not going to see things magically that the human eye can't see. So remember, LightningCast was trained only with ABI data, so it's only from a satellite perspective. And from a satellite perspective, it's very difficult to see in all this thick ice anvil where you might have lightning. So it kind of has low to middling probabilities in a lot of this anvil here. This is in northern Indiana. So the situation changes 5 minutes later, where now you have convection clearly poking out. You can see it well in the visible. You have this high texture, and you have higher probabilities now, over 75% right at the location of that convective core. And sure enough, 5 minutes later, you have your first flashes from GLM. So going back here, LightningCast can't see the convection that's happening underneath that thick ice. So it's, again, it's from a satellite perspective, it's not going to see things that you're not seeing. Now, of course, we could try to include radar data as a predictor, and maybe it would do a better job in this case here. Another case is a nighttime case from southern Kansas. You can see a lot of mid and high level clouds over the area. It's really hard to discern where there might be lightning potential in the near future from here, just from a satellite perspective. But I actually lied. This is not a nighttime case. this is actually a daytime case. So when I add in the vis and near IR, the situation changes, right? You can see some very agitated convection down here. So these probabilities up here are produced from LightningCast when we artificially took out the reflective bands. Now, when we add in the reflective bands, so it's the full model, situation changes, and it's doing a much better job of highlighting the lightning threat. Go ahead and play the scene. Right, so as that convective core starts to emerge from, or as you can see it kind of through the mid and high level cloud, probabilities increase rapidly and you get lightning. So this case shows not only the importance of the reflective bands in the model, but also, right, LightningCast isn't going to be able to see things that a human can't see. So it's not magic. Okay, LightningCast predicts lightning as observed by GLM. We decided to use GLM as our benchmark, our target data, because it has that spatial aspect that you just don't have with the ground-based networks. It gives you a footprint of lightning, albeit it's a rather coarse footprint. So we have to keep that in mind when we're interpreting these probabilities, right? The footprint's about 10 kilometers per pixel. GLM, therefore, is an overestimate of lightning, right? In a given pixel, you don't have lightning filling up that entire region. It's really just a small pencil stripe in that area. So there's the spatial aspect as part of it. LightningCast is also predicting next hour lightning. It uses just one timestamp, images from one timestamp of ABI data, but it has to try to anticipate lightning over the next hour during the training process. So sometimes it does that fairly well, but a lot of times it just can't do that. So what it does, it seems like it just kind of makes this uniform buffer around convection, kind of basically hedging its bets of where it thinks the convection might move over the next hour. So there's this spatial component, there's this temporal component. You also get some weird things like GLM artifacts. See this somewhat commonly where you get lightning like way outside of the cores of the storm. You know, someone mentioned here that this was actually potentially a reflection of the light from the lightning on the low-level clouds like 30 miles away, and somehow GLM was observing that. I'm not sure if that's true, but right, GLM artifacts are a thing. So all of this, we try to mitigate when possible, but all of this goes into the process of training the data, and therefore like interpreting the probabilities. So you can kind of think of it as probability of lightning maybe within 60 minutes and maybe like within 10 kilometers. Okay, and lastly, I really think LightningCast is a force multiplier. Provides automatic, quantitative, and objective lightning guidance all the time and everywhere. So hopefully it can help you guys quickly identify and prioritize threats and for specific locations, for regions. Provides probabilities as a starting point objectively, and with these time series, with these dashboards, maybe this is something you can even share with some of your more trusted partners. And but yeah, so last thing, oops. Not the last thing, a couple things, but basically next steps, where do we want to go from here? At the end of the hazardous weather test bed, last couple of years, one question we asked was, how would you forecasters rank some research priorities? So the first one here is just basically make LightningCast as accurate as possible in the 0 to 60-minute range. It basically just means keep doing what we're doing. The second one, having 2 time interval outputs. Some forecasters mentioned having a really short fused product like probability of lightning in 30 minutes. Third option was have 2 different flash rate outputs, probability of any lightning and probability of something more significant like 10 flashes in the next minute in the next 60 minutes at a given location. And fourthly, extend the lead time past an hour. So when we ask forecasters to rank these priorities, this was the ranking. The top one was to have 2 different time interval outputs of that really short fuse one and kind of the, I guess, what's become standard 60-minute probability. A really close second was basically just keep doing what we're doing. And surprisingly to me, a distant fourth was to extend lead time past 60 minutes. And I think this is either because forecasters intuitively know, then you start to get into model land, which is, less coupled with observations that in this case GOES provides. So they just intuitively know that the skill will decrease, or just the fact that maybe the tools in a longer time frame are suitable for lightning guidance. So to this end, we started looking at including MRMS. We're going to look hopefully at some model data, maybe like the 4-hour lightning probability from HREF. I think an area that will provide greater lead time and hopefully skill is using image sequences. So basically it's using a video you can think of as a predictor in your model. Now this is basically what self-driving cars do, but it does increase complexity and dimensionality of the problem. Using radar, MRMS, I think has a lot of, will have a lot of benefits. The one thing we want to be careful of is that we don't diminish lead time to lightning initiation, right? If the model tends to wait until there's more robust radar, then I don't think that's a good trade-off in my opinion, but that's something we can definitely look into. Okay, so lastly, I want to talk about these automated on-demand dashboards, and I encourage you all to use this. Basically, what you do is you can submit this Google form. So your URL is right here. Submit this Google form with very basic information, and you get an email, and then you will have this lightning dashboard available to you at the time of your event and at your location and for the duration that you define. I think basically right now we limit it to like 7-day duration. So this would be a way to get this type of data, these dashboards for these one-off situations like a state fair, county fair, big music concert somewhere, and things like football games that's Division II, Division III stadiums, things like that. So I really encourage you to look at this, and if it's useful, that's great. We want to hear about it, and if there's some ways we can make this more useful, we also want to hear about that as well. Okay, I think that is all. So I'm happy to take any questions, and yeah, thank you all for the invitation. Thanks for joining.
All right, John, thank you so much for this presentation. A lot of really good insights and information. For those to the last point John made about the on request dashboard, we'll have the slides posted along with the recording once it's processed. So for anyone wanting the link to that, John, I don't know if you want to share that in chat now, the direct link to access that. But we'll of course share the slides after the fact, so you'll all have access to it through our Eastern Region SSD webinar, a science sharing webinar Google site page. That being said, feel free if anyone has questions. I have 1 or 2 of my own. I say thank you, John, for posting that link in chat. Are there any questions from folks in the field about? Okay, so we got one. So the question, John, is: do you intend to train the model on more data, perhaps several years? Does the model algorithm change for each month? And I guess a question about November 19 performance.
Yeah, so we do plan to train on more data. We're actively doing it now. I think there is a point where more data is always better, but there is a point of diminishing returns where basically, it takes a lot of time to train these models. So are we getting our bang for the buck in doing so, right? We don't have hundreds or thousands of GPUs. So these take GPUs to train efficiently. We don't have hundreds or thousands of GPUs like Amazon or Google does. We use like 2 or 4, and that's fine. But I think we just want to be deliberate in, maybe adding 1 year of training and see how that affects things, then add 2 or 3, and maybe there's more improvement than I expect, but we'll see. So yeah, we do intend to do that. So yeah, model performance does change per month, as I showed before. Why was November 2019 so poor? I think one thing we found is that for tropical cyclones, the predictions are way too hot in general, especially for tropical cyclones out at sea. You don't get much lightning in those, but the model does think, right, you have really cold, thick ice. It does think there's lightning potential there. So I think possibly there were more tropical cyclones out in sea at that time, and so maybe that was diminishing the probabilities or the skill a little bit, but I'm not positive.
Okay. Well, thank you for that question,
Yeah,
Bob.
thanks.
Brian, go ahead, please.
I can't hear Brian.
I can't either. Brian, did you have a question?
How about now?
Low, but yeah, faint. We can
Okay.
hear you a little bit.
Okay. A success story. Yesterday, as you know, we had a severe weather event across West Texas. Once the towers started going up off the Davis Mountains, LightningCast was giving us probabilities before the towers started to glaciate. And we used the LightningCast in conjunction with MFA to issue an airport weather warning for Midland International Air and Spaceport. 25-minute lead time, roughly.
Oh, cool. Yeah, that's great.
And as you know, putting JP4 and JP5 into airliners and Lightning is not a good idea. So anything we can have to do to help those guys is great. My other question was this. If you're predicting future lightning evolution, would it make more sense to use MFA versus FED? Because FED would tend to show up more with mature convection, whereas with minimum flash area, that would be younger convection, shorter flash, more vigorous updrafts.
Yeah, that's a good question. One thing to keep in mind is right now we're not using any GLM as predictor data. It was only the truth or target data. So it's purely ABI doing the prediction. Now you could use, lightning at time 0 to predict lightning as well, in 60 minutes in the future. We've looked at that with the flash extent density. But yeah, I haven't thought about minimum flash area. That might also be useful. I guess I'm still a little hesitant to use lightning as a predictor, again, for the same reason as radar. I'm just a little afraid that we will reduce our lead time to flash initiation. However, I haven't looked at this enough, but it does seem like we have trained a model with FED and the ABI channels, but it does seem like the model is correctly emphasizing the imager data, the ABI imager data when there isn't lightning. So pre lightning initiation, and then just using the lightning data at the developing or more mature stage. So it's correctly emphasizing the data at the right time, I think. But in the few cases I've looked at with that, one other thing is that we just adding more channels and more data sources. There is some complexity where one goes out, then you start to get some really bad guidance degradation. So that's something to keep in mind too. But yeah, I will keep in mind your idea of using MFA. I think that's a good idea. Yeah, thanks for that.
That's a really interesting point, and one that I didn't even think of until just now as well, considering that difference between FED and MFA. So thank you, Brian, for that point and question. Really, really good one. Do have a couple of questions of my own, and maybe a poll will have here on a function of LightningCast. But that being said, are there any questions from folks in the field before I throw in my own? Well, if you're thinking of some, feel free to type them in chat, raise your hand when they pop up. So there's a function within, and John, please correct me if I'm wrong about any of the description. There's a function of a pop-up trend function within LightningCast that exists online to get a sense of data trends within the LightningCast product. Correct?
Mhm.
That's not baselined into AWIPS yet. Correct?
The right, that's not baseline to AOS. We do, yeah. We tested HWT where you just get a pop up and it's just the LightningCast probability over the last hour or something like that. Yeah, that's not baseline. Trying to quash one or two bugs in that. There's always some issue with AWIPS we're dealing with, but hope that got good feedback at HWT, and it's just something I think you would click or double click on a location and it would auto update and things like that. So hopefully we can figure that out and deploy that or get that baselines.
So we were curious to ask, to that point, how many folks in the field, even feel free to raise your hand. We can do it that simple across the board. If you want to stop sharing, just so, because I can't see raise hands. With the raise of hands, we're just curious to hear how many folks in the field are using that function. Feel just an informal poll. See a few hands going up. So there may not be direct knowledge of that. So that's a good thing to keep in mind of this feature. And John, correct me if I'm wrong, will you just double click in the online function at points, right?
So there's this ability in AWIPS, which isn't baseline, so I wouldn't expect many folks to have that. And then there's like the web-based dashboards. So maybe I can ask, like, how many people are aware or using the web-based dashboards that I showed about? Show of hands.
A few more hands popping up.
Okay. Yeah. So basically, that's just from our web page. I mean, I can demo it again real quick if I can share my screen. Right. Just Google search LightningCast. Here's the URL. You either click on a link here or you click on the layer. So if you want all the airports, you click on that. You can zoom in and I don't know, let's look at Philadelphia. Where is it? Here it is. So obviously so you click on the point, you click on the bubble there, the link in the bubble. There's no lightning going on now. Let me share this tab instead. Yeah, so this is what it comes up with. So I can look back at, I don't know, the last 30 days. You can even do like last fiscal quarter. I don't know why you'd want to do that, but whatever. So I don't know if there's been, yeah, so here's some lightning from earlier September. So this is only at a given point. So maybe that's useful, maybe that's not useful, but it's just an easy way to see how the lightning potential has been changing over time, and this interface we're using, this API is really nice and intuitive, and I think interactive. So I know it's not an AWIPS, this is on the web, so I don't know how much folks use the web versus AWIPS for different things, but hopefully you can at least take a look at it, see what you think.
No, it seemed like a few more hands went up for the dashboard side of this. So, and this is a really good tool. Looked into it a bit myself over time, and it sounds like some of you are already using it. So feel free to leverage it moving forward. It could be very useful, especially, of course, for IDSS purposes and so forth, situationally. So that being said, thank you, John, for showing that again.
Yeah.
Appreciate that.
Problem.
Were there any further questions from folks in the field about application, issues you've seen, maybe other success stories? Brian, you shared one from the Midland area. Thank you for that. Any other questions or wonderings you've had when you've used it situationally in convective events? Any of the above? Jack, go ahead.
Yeah, thanks, John. It was a great presentation and wonderful
Thanks.
work. A couple of questions I had. One, I was wondering about the display. Is it possible, or have you looked at comparisons with any NWP or guidance output in terms of some of the models and guidance that predict lightning threats? Is there any any skill, or can you see any of that on the visuals, or could you?
So you're saying compare it to the NWP guidance, and we haven't.
Yeah, particularly I was
Mhm.
thinking like LAMP or the HER or something like that. They have some fields that predict convection.
Yeah, we haven't quantitatively compared it to NWP directly. I do look at the href calibrated like lightning guidance, and I do see a lot of correlation there. So I think that might be helpful, and maybe we can use that, kind of combine model land and observations. So that would probably be my first start, rather than trying to. And I think nice thing about the href, right, combines, it's an ensemble, so it combines output from a number of models, and so that seems to be the best thing out there for short-term NWP based lightning prediction.
Yeah, I was just wondering if it was possible to put it inside the dashboard views to see some of the dot overlays, maybe, as a way to assess skill.
Yeah, that's a good idea. Yeah, these dashboards, we can put a bunch of stuff on there. We don't want to make them too cluttered, but we can just add another panel that might have everything, or sync in it. Yeah, that's a good idea. That would help us better monitor trends and see correspondence between our predictions and NWP guidance, stuff like that.
Okay. Yeah, two other questions I had for you. One was, it's maybe I missed it or not, but have you seen any skill differences like in the edges of the GOES domains? Or is it?
Yeah, at the very edges of the domains. Again, we haven't looked at this quantitatively, but you just don't have a complete picture. So I fully expect the skill to be worse. And anecdotally, we've seen this where if you just get like a very edge of an anvil, it might not be as confident or something like that. So there's some issues with the discontinuities. Hopefully, if you're using the Kona sector, that's not really an issue for you all. Obviously, with the mesos, that could be an issue. So that's something to keep in mind for sure.
And then my last one was about your research priorities you showed and ranked there. Is that a subset of the priorities, or those set already?
Those are the options we gave. If there are other things we should prioritize that you think or others think, that's something we could definitely look into. Did you have some ideas of what you would like to see?
No, I was just curious that it was, there was 4 there that, and I was like,
yeah, I think those were the options we gave them.
Or
maybe they had an option to write in a other or something like that.
Okay. Thank you.
Yeah, thanks, Jeff.
Thank you, Jack, for those questions. Yeah, that was actually one question I was going to ask myself, if there were any other things or if that was just the top 4, because one thing that was interesting to me is just the time interest up to an hour and not beyond that, like you mentioned, because understandably warning operations is happening on a sub-hourly basis. That's understandable, but outlook beyond that time, looking at the rest of a 3 or 6 hour period of, say, a shift as one example, is something that surprised me. I was just curious, did you hear, was there any feedback to that effect that people want that, or is that something you just didn't hear at all?
No, yeah, that was like dead last, like for almost every forecaster, which was really is a really interesting pattern. And I think it's basically what I said. Like there are NWP tools that kind of cover that, and when you decouple, NWP, from the observations, it's going to be something that's just inherently has more uncertainty. Also, a few forecasters mentioned to me that in the updates they give to emergency managers or event managers are kind of on that 0 to 60-minute time frame. They'll give more frequent updates, whereas ideally we would be perfectly confident that there's going to be lightning 3 hours from now at this location, but most of the time it's hard to say that. So a lot of the, like you said, the operation stuff happens in that the DSS communication, I guess, more frequent DSS communication happens, I guess, in that 0 to 60-minute time frame. Is that everyone else's experience too? Like, I'm just, yeah, because I'm curious how the DSS communication goes up.
So I will say, Bob LaPlante Cleveland noted that the CWC-METs might want a longer projection.
Yeah.
So that's one thought, and understandable from an aviation standpoint.
That's a good point.
Were there any folks across the field on the call still who have had different experiences from that collective feedback, or I guess we'll take silence as agreement? All right, it seems everyone agrees with the feedback that has been submitted up to this point on that topic. Coming up on, a little bit left to the top of the hour, are there any further questions or thoughts or wonderings about any of the future activities of LightningCast and where it's heading? Or I guess it was pretty clear. All right, I guess you really just shocked everyone away from any further questions.
Yeah. Yeah, so Jack says her lightning threat field would be interesting to.
Yeah. The thing that Jack brought up, an interesting point, would be even something as simple as on the dashboard side of things, to have a selectable field where it's not coming up automatically, but you can select or unselect.
Yeah,
perhaps.
that's easy to do. Mm-hmm.
Yeah, model data, importing that so you can get a sense of comparison. So that's a really, really good idea. And I like that a lot too.
So this is giving you flashes per kilometer squared per 5 minutes. Yeah, so that's really interesting. That's something we definitely look into, just putting on the dashboard and seeing how it does.
No, that sounds really great. And a great point of comparison, and a great ability to compare the data efficacy and the output accordingly. All right, I'll open it up. Don't be shy. Any final questions or thoughts? All right. Well, if nothing else, John, this is really great. Really duplicating this information was helpful, and hopefully you all found it helpful as far as insights and how to bring it back into operations even further along than maybe it already has been up to this point. And really just appreciate everyone's time and all of you in attendance this morning. John, thank you so much for your time. And that being said, of course, this has been recorded. I'm just going to reiterate. I see some exciting emojis of appreciation, so thank you to John again. It's been recorded, so we'll have it up as soon as it's processed at a higher level than myself. We'll get the recording slide and the slides from John as well uploaded to our Eastern Region SSD Science Sharing Webinar Google site. And we will go from here. So I guess, again, thank you all so much. John, thank you very, very much.
Yeah, thank you for having me.
And really appreciate everyone's attendance this morning. And I wish a great rest of your Thursday to everyone here. So have a great day.
Thanks, Jordan.
Thank you.